Good afternoon, everyone. Welcome to the Georgia Smart webinar series. Thank you for joining us today. I'm Greg McCormick, Director of the Georgia Smart Communities Challenge. Before we get started today, a few housekeeping reminders. Please keep your microphone and video muted to eliminate any interruptions. This webinar is being recorded and will be available on the Georgia Smart website for viewing at a later time. And the slides will also be available for download from our website. Our guests will be answering questions at the conclusion of the presentation, and we'll be using the chat area to read your questions at the end. So please familiarize yourself with the chat area of BlueJeans to submit your questions at any time, but we'll be answering them at the end. Today's webinar is number 4 in our 2019-2020 series, where we bring you Georgia Tech professors and researchers to discuss ideas and topics in smart communities and the related policy, technology, and innovation supporting our move toward a technology-driven digital future. We'll be hosting one more webinar this season at noon on April 14th, so we hope you can join us for that. If you have joined our subscriber list and receive our monthly e-newsletters, you'll receive invitations and reminders for all of our events, including that webinar. And if you'd like to subscribe to Georgia Smart newsletter, you can do so from our news area on our website. I've made those links available in the chat area for your reference. So without further delay, we're very excited to have with us today Dr. John Taylor. He's the Frederick Law Olmsted Professor in the School of Civil and Environmental Engineering here at Georgia Tech. His research in the Construction and Infrastructure Systems Engineering group focuses on the dynamics where human and engineered networks meet, and his work seeks to improve urban sustainability and resilience and guide the evolution of smart cities. Professor Taylor became the Associate Chair for Graduate Programs and Research and Innovation in the School of Civil and Environmental Engineering last July, and he leads the Network Dynamics Lab. Dr. Taylor's presentation today is titled Smart Cities, Digital Twins. Welcome, John.
Thank you, Greg. It's exciting to be here today and talk about our work on smart city digital twins. We introduced this concept in 2017, and it seems to have drawn just a tremendous amount of attention in just a very short period of time. Some research ideas seem to take a long time to mature in and get people excited to talk about it, but this one seems to be growing very quickly. So in my presentation today, I'm going to give first a little bit of background. How did we get to smart city digital twins? What kind of research prepared the groundwork, the foundation for this work? I'll describe what I mean by smart city digital twins and do some further motivation as to why to focus on cities in particular. Oh, hold on just one moment, please. Sorry, we had a little technical difficulty where you couldn't see my slides. Hopefully you now see them up on your screen. So as I was saying, I'll present a bit of background on how we got to smart city digital twins. What do I mean by smart city digital twin? And then I'm going to give some examples from really around the US and around the world, and including Atlanta, but all based on the 5 pillars of smart city in the city of Atlanta. And then I'm going to describe some work we're doing as part of the Georgia Smart Communities Challenge with the city of Columbus, Georgia. So let me get started. The background, at least where our group comes from in terms of our angle, is smart buildings. Get one thing fixed on the screen here. Okay. And so our lab's vision since its inception about a dozen years ago is really to first understand, then to do, we're engineering lab, so analytically model, but also try and improve things that are occurring at the intersection between human and engineered networks. We started out, if you're at all related to the building industry or working in a city, you probably have heard the term BIM, Building Information Modeling. So 10, 12 years ago, that was a big change that was occurring in the industry, and we were, the researchers are out there trying to figure out, all right, how do we move these BIM models from being just representations of the buildings to having intelligence? So what kind of data can we get into the buildings, and how can once we put intelligence into the building information model, how can it transfer from one company to another? That's an important foundation for smart city digital twinning. But once we had done a bit of that, we started to think about the model in other ways. So instead of just using it to, as a set of plans for the building, could it become a space for collaboration and feedback? And so in the images you see here are one of the early projects we did with Skanska, a large building construction company. This is a Boeing delivery center in Washington State. We took the BIM model and made it into a collaboration space where the architects, engineer, and contractor could come together and actually visit the building. In the image on the left, it's a screenshot of the application looking at the outside of the building, and on the right is a screenshot looking inside the building. The screens you can probably see there on the wall in the center of the picture on the right are real LCD screens in the building now, but in the virtual version, they were points of collaboration where people could pull up a set of 2D plans and actually have discussions about the building looking at the specifications. And now I'm just going to animate in a couple of pictures of what the real facility looks like now that it's complete. We took that concept a step further. We were interested in that case, the previous case, it was about the stakeholders that are working on a project collaborating. And we wondered, couldn't we use these same models to capture information from future stakeholders, the occupants of the building, or even the members of the community? And so the animation you're seeing is an application we developed for collecting stakeholder feedback in advance of construction for the Candida building for innovative sustainable design on the Georgia Tech campus. It's designed to be the most sustainable building ever built in the Southeast. And the little different color hash marks you see are things that people, stakeholders, typed in related to each of the 7 areas of the living building standard. And so here someone has selected an area of the model. It's a touchscreen based application that works on an iPad or an iPhone, and was able to put some feedback into the model, which we later were able to analyze and look for patterns where people had identified things that maybe didn't suit them well. We wanted to see, is that even the best approach? The previous one you can see is all virtual reality. So we created an augmented reality application that does the same thing, where you can walk out onto the job site. However, in this case, the construction fence was up, so you couldn't go in, but you can see on this iPad that the model of the building is right there where it's supposed to be. And if this individual were to walk closer to the building, they could actually walk inside the building. And so we can see how these digital twins of a building can facilitate stakeholder engagement. Expanding further from there, this is an educational institution. We brought together interdisciplinary teams from different universities into those models to collaborate and to do design and building retrofits. Here, the logos on the right show universities from India, the Netherlands, Finland, Turkey, and a number of universities in the United States who have worked with Georgia Tech, who's the center of this collaboration in the cybergrid, cyber-enabled global research infrastructure for design. Now, all of this is really focused on the models themselves and how the models can be useful. But as we think forward in the use when a building is actually in operations, there are other opportunities, other applications, one of which is energy efficiency. And so we spent a considerable amount of time, I'd say half a decade ago, figuring out ways to use the BIM model as a form of feedback for occupants on resource consumption. In this image here, you're seeing on the left energy use data for different rooms in a building, and on the right, the relative intensity of energy consumption in those different rooms to use the BIM model as a way to provide occupants with information about the energy consumption of the building and ways that they might be more efficient in that consumption. There are other, so the buildings we've actually done, this is a multifamily residential building in Manhattan. So we've done this in large scale residential settings and also in commercial buildings to see do these feedback systems, can that digital twin that provides energy use documents of a building actually result in reductions in energy consumption? And in both cases, we found statistically significant reductions in consumption. So these models can certainly help at a building scale. We also, about 5 years ago, started to think about other applications beyond resource consumption, and we came to disaster mobility. So this is another instance where human systems are interacting with infrastructure systems, infrastructure networks in an important context. And so the image you see at the right are individual locations captured through social media during Hurricane Sandy in New York City. The red areas in the map on the right are the mandatory evacuation areas. And you can see that some of those people that are posting during the hurricane are actually in those mandatory evacuation areas. The green dots are unfortunate fatality locations, and you see many of those are in those mandatory evacuation areas. And so, if we expanded this concept of digital twin beyond a building and scaled it up to the community or the city, could it provide residents information they would need in a disaster situation to make informed decisions or better informed decisions about how to react or how to evacuate? So with all of that as background, we expanded our mission from just looking at understanding, analytically modeling, and trying to improve things that are occurring between human and engineered networks to really starting to look at that at different scales and across scales. So not just the building, but moving from the building to the community, from the road to the community, and from the community to the city, so that we can actually achieve smart, sustainable, resilient, and livable cities. And that requires actually pulling together all of the expertise from those 5 areas that I just described to you. Now, this might sound a bit science fiction, and so just for a little bit of lightness, let me share an interesting story that ended up creating a National Science Foundation workshop, or was the Nexus for one. In 1900, at the World's Fair, there was a lot of excitement about the turn of the century, and a company commissioned a bunch of artists and intellectuals to work together to figure out what might life look like 100 years into the future in the year 2000. The company actually went out of business, and the cards were never distributed. They were placed in a basement, and the company ownership changed hands. And then in the 1950s, a gentleman who was working in the company found a ring in the floor, pulled it up, and found a basement. And in the basement were these cards. All of the decks of these postcards were damaged except for one. And somehow that one that survived made its way into the hands of Isaac Asimov, a very famous science fiction author. And he tried to investigate whether or not people were able to make decent predictions about the world might look like 100 years into the future. They envisioned things like a machine that would go around your house and do the cleaning. They envisioned instead of taxi cabs, which you can imagine this is very early even in mobile transportation, that would fly you to your destination. Here you see there are aero cabs that take you to your destination in the city. Firefighters that could fly and fight fires better and bring people to safety. And for educational institutions, this is of course my favorite. Here the professor is putting books into a grinder. Someone's grinding the grinder, and then that goes through the wires and directly into the heads of the students, if it were only that easy. But we thought, we were inspired by this work by Isaac Asimov and the work of these artists and intellectuals from the late 1800s to think about how cities might be different in not necessarily 100, but 10, 20, 50, 100 years. And so we received some funding from the National Science Foundation to do a workshop on From Science Fiction to Smart Cities. And the group of people you see there doing nanu hands are predominantly faculty, but also from national labs across the country. The editor of ENR is there in the center. We got together in groups and did exercises to try and envision what that future might be. Well, one of those futures, that workshop was, I think, 4 years ago. was, could we create a digital twin of a whole city? Could a city become smart? And if a city were smart, what would that mean? Well, I think a first question is why focus on cities at all? A lot of the examples were related to buildings. Well, people are moving into cities. So this image in the center is an artist's interpretation of what Manhattan looked like in 1609, and then a photograph of what it looked like in 2009. So it took 400 years for the city to grow to that size as the mega city, or one of two mega cities in the United States. But what the UN is saying is up to 70% of the world population is going to move or live in cities by 2050, which means we'll have 2.5 billion more people in cities. Well, that means we need 1.5 million urbanized people per week over the next 25 years or 30 years, which is essentially a new New York City every other month, which is kind of hard to imagine. We're going to need to use technology to make sure that this is done effectively. And this is also shown in research that there are concerns when you start to scale up populations. This work, largely by Jeffrey West from the Santa Fe Institute, investigates how human interactions and socioeconomic activities scale with population size. Well, as the population grows, we don't just get, 2 times the amount of income, wealth, and innovation when the population doubles. We get 215%, right? There's a superlinearity where there's even more benefit in terms of income, wealth, and innovation as population sizes grow. But along with that come negatives with their superlinear growth in terms of crime, pollution, and disease. On the flip side, where infrastructure networks, our physical infrastructure is concerned, it scales sublinearly, right? So if we have 2 times the size of the population, we don't need 2 times the infrastructure. We need 1.85 or 185% because it scales sublinearly. And so there are certainly interesting interactions that are occurring at this human and infrastructure network interface that are important to understand and perhaps can be improved through the use of technology. So we came up with this idea of smart city digital twins, basically wanting to do exactly what I said, trying to figure out, can we scale up what we can do with buildings, with roads, to the community and all the way up to the city through digital twinning and integrate these infrastructure, human, and data dimensions. So what is a digital twin? First, the concept of digital twin it has existed for at least a decade. General Electric uses it in a lot of the publications you'd read about it, talks about how they use it to model their factory floor. And what it is a pairing of the virtual and physical worlds, right? So you have this virtual version of the real system that is pumped full of data and allows analysis of data, that real-time data and monitoring of the systems, with the idea being that you can head off problems before they even occur, that you can prevent downtime, and that you can develop new opportunities and plan for the future using simulations. You can identify, different scenarios of the future and what might happen if this machine were to go down more soon, or what if we placed a new machine here? Well, in the context of smart city digital twins, we adapted that definition to describe it as a smart, Internet of Things enabled, data-rich virtual platform of a city that can be used to replicate and simulate changes that are occurring at that human infrastructure interface, and that this can be used to improve resilience, sustainability, and livability in the real city. And so the image you see at the top on the right is a virtual version of the city of Atlanta, a smart city digital twin of the city of Atlanta that we've developed. On the left is a photograph of the city from that same perspective. And so we're looking at the deltas. What is changing in the real city? How do we model it in the virtual city? And what can we learn about the city through the use of this smart city digital twin to improve the resilience, sustainability, and livability? There are 4 aspects to smart city digital twins that we've outlined as we've defined it in the literature. First, we're using it to understand what's happening in a city, right? Just looking at the data to understand what are the mobility patterns, for example. Second, why is it happening? Looking for correlations across different data streams to understand why there might be traffic at this intersection, why this building might be using more energy or water, and then evolve to scenarios. What if blank were to happen? What if we were to close down, for those of us in Atlanta, another lane on Spring Street? It seems like there's a new lane closed every week. What effect would that have on traffic? Well, I can tell you traffic is pretty bad on Spring Street in Midtown. And fourth, could a smart city digital twin actually act on our behalf? So in the background of this picture, the reddish building, kind of to the middle left, even though it looks smaller, is the Bank of America building. It's one of the tallest buildings in the United States. It sits on our smart North Avenue corridor in Atlanta. And, a intervention could be if there were any type of emergency that required evacuation of that building, could the infrastructure actually react to divert traffic away from that location, to stop traffic right at the location, to maximize the number of people that can evacuate to safety from the building in the critical first minutes before first responders were to arrive? Now this, as I mentioned at the very opening of the talk, the concept of smart city digital twins is gaining a lot of traction. We were ourselves quite surprised to see a analyst report come out in September of 2019, so just a few months ago, that argued or predicted that the number of smart city digital twins would exceed 500. So 500 cities would have something like a smart city digital twin by 2025, just 5 years from now. Well, there's a tremendous amount of research and understanding that would have to take place for that to achieve the kinds of things that are described on the left-hand side of the slide here. But we absolutely think it's necessary, given the fact that the number of cities is going to grow by so many, or the number of urban residents is going to grow so much over the next 30 years as predicted by the United Nations. So the next part of the presentation, so I've explained what is a smart city digital twin, and we can discuss it more in the Q&A. How did we get there? And now what I'd like to do is just give some examples on how we're using smart city digital twinning in the 5 areas, the 5 pillars of smart city of the city of Atlanta. The cases aren't all in Atlanta, but Atlanta has mobility, public safety, environmental sustainability, city operational efficiency, and public and business engagement as 5 important pillars of a smart city. If we're going to implement smart city technologies, processes, and so on, then it should create improvements in these areas. So a first study I'd like to share in the area of mobility is one we did in the City of London. So the blue dots you see scattering around Greater London on the map are people's locations over the course of a day. And you can see there's some dissipation that occurs in the, let me rerun that simulation. People come into the center of the city. It's brighter blue in the center of the city. They'll start to slowly disperse back out to the suburbs at the end of the day. And what we were curious about was, could we use those movement patterns of the urban populace to understand differences in energy consumption in different areas of the city, what are called middle and lower super output areas in London? And we found that we could explain differences in energy use, and that those differences in energy use could help the City of London to actually do better energy efficiency interventions across the city. In the United States, in Chicago, what you're seeing on the left are people's mobility patterns over 24 hours. Again, you can see it getting blue in the center. In this case, it's repeating. So we're seeing a day and then another day and then another day. And on the right is a heat map of energy consumption in the city. So in London, we were able to use the digital twin in order to understand energy consumption over the course broadly of the whole city. Here, we're looking at more specifically fluctuations in energy consumption based on people's daily patterns, right? Does energy consumption move with people? We found that it did, which is perhaps not surprising, but would be very important to as we develop future plans for distributed energy in cities. And then a last mobility example, that is the city of Atlanta. The dots you're seeing appearing are people's locations. In this case, we were interested in investigating how the pattern of movements in the city is evolving over time. And so the center of gyration or center of mass of all movements in the city, on the right, you see an orange dot at the bottom of a black arrow. That's where the center was in 2014, but you can see a somewhat substantial shift north in the movement patterns of all the occupants. So that's a bit of an intellectual question where it becomes more of a perturbation. How a disaster, in this case, I-85 bridge collapse, what effect does that have on people's mobility patterns, and how can a twin of the city help to reroute people to address this very substantial disruption in the daily commute of Atlanta residents? The second area of the smart city pillars is public safety. Here is we've developed a digital twin of the Earth system in Oklahoma together with a geologist, and we're linking that to the human system. So how are people moving around? How are people communicating during an earthquake? And interestingly, we found that there are what we can call human quakes as well, where the information flows sometimes faster than the speed of the earthquake. That first T1 that you see there, the earthquake is the Pawnee 5.8 earthquake that occurred in Oklahoma a couple years ago. The star is the epicenter. T1 is the location of the center of all social media postings related to that. And it was observed there before it was actually felt. So social media can be a powerful and speedy way of understanding what's happening in a natural disaster. This image you're seeing here is actually locations during a Napa Valley earthquake. And the Roman numerals are the severity of the earthquake in that location. And you see they're not neat and tidy concentric circles. It depends on the specific ground conditions at that point. And we were interested here in understanding, does the degree of negativity, does the sentiment of what people are communicating through social media actually correlate with how much danger they're actually in? And we found that there was a significant correlation in that earthquake, that the more of a dangerous environment you were in, the more negative the sentiment was. Well, we used that information to develop a system with funding by the National Science Foundation to examine social media postings, and now we're also doing one with the Georgia Department of Transportation, to see can we use social media postings, the degree of negativity in their locations, to identify significant areas during a natural disaster that might need help. The picture on the right is during Hurricane Maria. That's a tree down over a power line. It's actually right in front of my house. I didn't realize that when a power line touched the ground, it might actually spark fire. You can see it sparking fire, and I can tell you sidewalk turns into glass when it's been sparked with fire in this case, like this. But on the left, you see some hexagons with the social media posting activity in the greater Houston area during the hurricane. And the redder the hexagon, the more and more negative social media postings that there were in that area. And you can then drill down on one of those hexagons and see what exactly were people talking about. We created you can see in the flow at the top, a way of identifying geotopics. These are spatially related social media postings that are on the same subject. So you see in the upper left of this 8 postings related to evacuation. That was near a hospital where people needed to evacuate. And on the bottom right, more related to flooding. And so we've developed a system to help cities to identify where are the specific crises occurring within a larger crisis? Now, moving on to city operational efficiency, certainly one aspect of operational efficiency is consumption of resources, energy and water. We took all of the buildings on campus and their energy consumption in order to create a system where you could see easily, visually, and intuitively which buildings are using more energy. There's a slider bar where the person who's interacting in the virtual environment can actually change the time when they're interested, and then you can see it's paused now. But on the building, the green building on the bottom left, 9.25 kilowatt hours, it gives you the actual, you can see the consumption of each of the buildings too. Then you can click on the building and get more information about that building. On the right are the facility analytics director of the campus and one of her team actually trying out the system. Now, that system is useful to facility managers, but you may have gathered from the earlier discussion on what got us to this point, we're interested in directly interfacing with citizens. So we created an application that uses that same Smart City Digital Twin data, but it operates on a cell phone. And so now this person's walking around the campus. When they get within 300 feet of a building, an icon pops up, and you see the College of Computing icon popped up there. The color of the icon indicates the relative energy consumption of that building compared to other buildings of its same type. And on the bottom, you can see a map of which buildings you're seeing and a summary of the relative energy use of those buildings. Once you click on the building, you get information about the building on its energy consumption. You can also get information on the supply. So this is showing that for this building, what is the actual origin of the energy consumption. And this project was related to helping the citizens of the campus, otherwise, the students, faculty, and others, to understand, where does the energy come from, with an idea of helping them and helping the campus to achieve its renewable energy goals. And then on the far right, there's an animation of the application where you can also look in more detail at the consumption of the building to see, how is it doing against its goal, against the campus goal? Is it actually helping Georgia Tech to achieve its objectives? And so this is an example of environmental sustainability of the campus. And we have gotten data from the city of Atlanta to develop and run something similar in the city, as well as some funding from the National Science Foundation to do a more meaningful connection to the buildings to see not just the energy consumption, but also some other details in commercial buildings related to the effect of reductions of energy on comfort and productivity. The last of the 5 pillars is public and business engagement. And for this one, I'm going to give a slightly more extended example because it ties together, ends up tying together really all 5 of those areas on a project that we're working on now that is very clearly a Smart City Digital Twinning activity, and one that we're extending into the city of Columbus, Georgia, with collaborators there. So we have an area of campus that we've described as a super block that contains a number of important different types of building, like the Candida Building for Innovative Sustainable Design that I showed you earlier. At this point, it was just a parking lot there on the bottom of the graphic. There's parking deck, there's a LEED Gold research building, there are commercial and research buildings, a campus safety center that's been built, residential buildings. So it's like a community. And we were interested in understanding and providing access to the people moving through that space, stakeholders, to give feedback on what they're observing in that space, but also for us to collect data on what's occurring in that space. And so we purchased and partnered with Argonne National Lab to deploy 2 array of things sensors, and I'll explain what those sensors do in a moment. with the goal of creating a smart corridor on the campus. This brick area that you see is a pedestrian and bike throughway that crosses two busy intersections at 1st and 10th. And we wanted to be able to provide information about what's happening along that corridor that may explain differences in movement patterns. We wanted to give people the opportunity to actually communicate about, what they're seeing on the corridor. We created an application called CitySnap. What that does is allow people to, as they're walking around, take a picture. And the hashes that you see there are previous pictures that have been taken of something that they're observing in the space, in the smart corridor, and put a piece of feedback about it. And you can imagine that we can analyze the sentiment of that. We have its location. We have some information about the users in order to see, is this issue that a person is typing in something that is generally true? Is it equitably true? Is it just one demographic that has this issue? Is it several? And then we can, in this case, this is the different postings of that individual. But in the lab, we can look across all postings and see where, that there is more negative commentary and what that's about. If we're focused simply on the citizen feedback data that we're getting through the app. But again, the idea was to correlate that with other types of data. The array of things sensors that we've deployed cover things or measure things like ambient air quality, and the various aspects of that are described there. Sound intensity, what's happening on the street, how many people are going by, how many bikes are going by, how many cars are going by, is it a car or truck? It would detect bigger vehicles, what are the weather conditions, cloud cover, and so on. Is the array of things node. Additionally, since we have the partnership with the facilities on campus, we also have information about resource consumption in buildings, which we can feed back through the Smart City Digital Twin. And then lastly, we're collecting that citizen feedback through the CitySnap application. So I wanted to show two examples of how someone would at least interface, or one could interface virtually with all of this mix of data that we're talking about. And this is going to be a health example. So it's looking at monitoring violations of World Health Organization thresholds for health harmful pollution levels, and correlating that with people's perspectives. On the right, the person is clicking through the CitySnap feedback from people that are walking through the campus. They're also selecting through the middle graph. The middle graph is showing the relative percentage of different air quality components. And what they've done just now is pull out a graph on the ground where they can kind of visually, intuitively, and quickly see how those different measures correlate. So you remember, and you can see on the left why it happens is an important component. Well, here you can see the tightest correlation is between humidity and temperature, but there are also other correlations of interest between these. So we can understand at this particular moment in time, why were things happening the way they were happening. A second example, you can also go into the building. And so in this case, monitoring variations in water and energy consumption levels correlated with human activities in the building. So once you're inside the building, the heads-up display changes. Here, we're able to see consumption of water and energy and occupancy. And so that when they're clicking a moment in the graph, they can go to the right-hand area and actually see what were the social media postings during that time. They can pull the data out onto the ground to kind of visually and intuitively identify where are the peaks. If they click on one of those peaks, they can see what was happening, with the social media activity. And there you see they've clicked on it, where we were able to identify that there was some leaking in the water fountain, which may explain why the water consumption was higher. So that is a specific example that we're doing. Let me come back to how cities can benefit from this if it's deployed more broadly. In terms of what happens, we can monitor the IoT, Internet of Things sensor data that we're collecting across the city against some thresholds, right? If it exceeds some predefined threshold, then we can take action. We can look at data across different types of sensor data feeds to identify correlations. Why is this effect happening? Might it be related to something else that's happening? Could traffic on the street be affecting the movement of pedestrians on the sidewalk? Perhaps more to the point, for those cities that have e-scooters, are e-scooters changing the walking patterns of urban populace? And allow citizens to provide feedback so we can use that among the correlations to understand what anomalies might be occurring out there in the city. At the next level up is scenario-based predictions, and this seems to be the gold standard as we go around and we talk to cities. They definitely want to understand what's happening. They definitely want to understand why it's happening, but they love to understand, if we made this a change, what effect would it have? Well, that requires collecting sufficient data up front. What's nice about the scenario-based predictions compared to just simulation is if you do a simulation today, and in a week you rerun the same simulation with the same data, for all intents and purposes, you're going to get the same kind of answer. In a smart city digital twin, where it's based on real-time data, each time you run the simulation, it's going to be based on a slightly different set of data, right? So next week will be based on everything that happened before now, but also everything that happens between now and next week. And so when we make that scenario-based prediction, it's based on everything that's occurred right up to that moment. And then, I think there's still a lot to figure out before a smart city digital twin can actually intervene on our behalf, but it's certainly an opportunity to automate, optimize, and improve cities if the infrastructure can take some steps on behalf of its citizens in, for example, the critical first minutes of a disaster before the response crews arrive. I wanted to finish with what work we're doing in Columbus with Columbus City government. This is I think it's a Google Street view of the city, just to show we are going to start out. We're actually, the plan is to install the Array of Things sensors and a few Wi-Fi access points next Friday, the 31st of January. So this is all happening real time. We're going to start off with the two on the right at 10th Street and Broadway, and at 11th Street and Broadway. And we expect in the pilot to expand to one or two additional Array of Things devices at two other corners so that we can model an entire block. What we hope to be able to do there is our plan to do, use a combination of existing sensors that are in place, the Array of Things sensors, sensor nodes, multi-sensor nodes, and the Wi-Fi access point network that's going to be installed to study mobility patterns in that block, to allow citizens to connect to and to feed back what's occurring on that block, and then to create, and so we're in the process of creating the digital twin visualization for that area of the city of Columbus, so that we can go beyond just the numerical analytics, but also allow people to experience the city through augmented and virtual reality. And over the course of the next year, plan out how this might be expanded to cover more of the uptown area. So what are the benefits of smart city digital twinning, in particular in Columbus? Well, we're hoping it can equip Columbus government to better understand how people are moving through the uptown. That's of considerable interest to the business owners in that particular area. So they're eager to understand these mobility patterns and what drives more and less people moving through the uptown area. to improve understanding of the impact of climate, air quality, noise, and other factors on people's mobility patterns. To create this digital twin of the uptown that has tools and resources for business, government, and the public, to improve public safety at intersections, for example. And at that final fourth level of intervention, the hyperlocal data can help Columbus City government to anticipate and address potential problems. In the near term, that's providing them with alerts when certain thresholds or combination of data thresholds are crossed. But down the road, and of course, and certainly during the project, we'll be thinking through what are specific things that could, done to enable the Smart City Digital Twin to directly act in the benefit of the citizens. So just to kind of circle around back to that Isaac Asimov future days, if you remember, there were the 4 areas that were predicted in 100 years, things would be very different. Well, I have in my own house, so we've named it Max, something that does approximately what they envisioned in the late 1800s. In terms of firefighters are actually using drones to help the efficiency of firefighting operations. The upper right, the professor dropping the books into the grinder and it going into the student's head, not exactly, but we do have an artificial intelligence teaching assistant at Georgia Tech who started a couple years ago and has actually won a teaching award. So that's certainly happening. And then the last, the AeroCab, the first drone taxi. Drone picked somebody up and delivered them from one point to another point in Dubai just, I think, a year, maybe 2 years ago. And so they weren't that far off. The pictures weren't correct, but the concepts were there. And so we pulled together that group that I mentioned before, but then again, this past September 2019, we brought a larger group and experts from different areas to think through not just science fiction to smart cities, but specifically, what is it going to take to successfully do smart city digital twinning in cities around the world? And this brought in people experts from NASA, from the national labs, from academics from that first group, but also now a larger group of academics, people from industry that are doing novel and interesting things on the sensor side and on the application side, and folks from city and federal governments. And our collaborators from Columbus are actually there on the far right-hand side of the picture. And we think this is really important for sessions and workshops like that to occur, for work that's happening in the Georgia Smart Communities Challenge, for the work that we're doing specifically in the Georgia Smart Communities Challenge. If the UN is right and people are going to move into cities at the rates that they're describing, and it's only been a couple years since the number of people living in cities exceeded the number living outside of cities for the first time in history. So the trend is definitely occurring. And if we're going to have 500 smart city digital twins by 2025, then we're going to need to do a lot of research, a lot of work like the work we're doing with the City of Columbus, with the City of Atlanta, to figure out how to do this effectively so we can have not just smart, but sustainable, resilient, livable, and equitable cities. And with that, I'll conclude the presentation, and I'd be happy to discuss Smart City Digital Twin further through your questions.
Thank you so much, Professor Taylor. Very engaging webinar here this afternoon. It's really interesting to see the future coming true with the slides from Isaac Asimov. So very interesting. We do have a couple questions that have come in so far. So Professor Taylor will take these, and any additional questions that you submit, again, please use the chat area to submit your written questions. We will not be taking questions verbally.
Thanks, Greg. So the first question that I see there is, how long before this can be implemented in larger cities? It is happening. There is an example from industry where Dassault Systems has worked together with Singapore to create a digital twin There are versions of digital twins that don't necessarily cover all infrastructure systems that are in operation in New York City. One of my collaborators who is part of this has done a water digital twin for New York City. We have the Argonne National Laboratory collaborator. They have deployed those array of things throughout the city of Chicago. And what's interesting about those is all that data is publicly available. So anyone that wants to see, what's happening in the city of Chicago can go and access this data and see what's happening. I think the issue that we raised at this workshop and the issue that really needs careful consideration is, the first step in the evolution is, what is happening? But when it gets to the next step of why it's happening, well, then you really need to understand across infrastructure systems, across different types of sensors. And so what exists are many examples of cities that have one or maybe two infrastructure systems that they're examining how people are moving and living and consuming over, but we lack examples that actually bring together the many sensors, the many infrastructure systems to have a full and holistic understanding of what's happening in cities.
So the rest of that question was, how can we access the slides? So the slides and a recording of this presentation are going to be available on the Georgia Smart website. If you go to the home page and then within the menu area towards the top under news and media, if you click on media, that's the page you want to be on to be able to access a listing of all of our webinar, and that'll have recordings and presentations that you can download. And then I think the other question had to do with contact information. Professor Taylor has that information up now on the last slide for you to see.
Okay, the next question, what kind of things do you consider when deciding what IoT data to capture? Do you need to know the what if questions in advance to capture the right data? From where I sit as a researcher, there's a paucity of data, right? There's not that much data that's readily available to us. And so unfortunately, it's what data we can get access to that determines the kinds of things the kinds of data we can collect, and therefore the kinds of things we can study. We're very excited to work with on this Georgia Smart Communities Challenge project with Columbus because we're going to be deploying sensors together. We're deploying sensors, they're deploying sensors, there's some sensors in place. And so that really was a first opportunity to sit back and see, well, what should we consider if we're going to go out and do this deployment? Obviously, what sensors we have already access to, but what kind of problems or issues or opportunities are we hoping to address? And so we had a stakeholder workshop in December, bringing in various stakeholders from the public, from the city council, from government, from the businesses, and others. That's pretty much the groups that were represented. Greg was there as well. And really discussed with them what are the kinds of things that they think a smart city should do, what are the opportunities, how could their lives be made better. And so we're really, we're going to do another one of these, but trying to tailor the solution to the identified needs of the stakeholders. And so once you have identified those needs, and as we have begun to do, you can start to figure out which types of sensors you want to collect. Do we need to know the what if questions in advance to capture the right data? I think if you know the scenarios, then that would certainly guide you in the right direction for collecting data. But this is very much a learning process, right? There aren't examples or enough examples where digital twins are doing this type of scenario-based forward thinking. And so a lot of it is driven by what's in place.
So the next question is asking about data. and state-of-the-art strategies related to how to manage it, store it, update it, retrieve it. Professor Taylor, do you have any comments on that?
But what I can say on this, I'm not a computer science professor, I'm civil and environmental engineering. We're certainly working with a lot of this, but the data issue with some of the sensors kind of comes with the sensor. So in the case of the array of things sensor, that information is streamed. Argonne National Labs takes care of that. You can actually stream it to your own server, and we do that. But the decisions on the storing, updating, and retrieving are by the people that are providing the sensor. I know from talking to city governments, often the people that are providing the sensor technologies that are deployed in the city define these things, and even the rights of the city to what amounts of and specific data can actually be accessed. Almost in some cases, like a pay-as-you-use model, right? So even though the sensors are deployed in the city, because there's a tremendous amount of cost involved in creating and deploying these sensors, they will often charge cities to access some of these data. So the next question that I read here: how to get local regulations to encourage better use of emerging concepts like the living building. Is it possible to make the Atlanta Beltline a living building zone where the Beltline produces the power it needs for transit? That's a wonderful idea. We have the project that I described on campus was really, it was defined as creating a living campus, right? Allowing people to engage in through the stakeholder feedback app, CitySnap, providing a pulse of, what people are thinking and what's really happening through the combination of the stakeholder app data and the sensor data that's flowing, so that we can actually treat it like a living campus. I really like the idea of making the Beltline a living building zone. I think that would have a lot of traction with people if it can be made to happen. I know there's certainly a relationship with aspects of smart city in the Beltline. I know there's a speed governance zone for the e-scooters, a geofence that has been set up, and so if you're in that zone, you just can't go faster than a certain speed. So it's I know it's not the living building point, but anyone that's been along the Beltline knows that it's very crowded. So having a speed limitation for the e-scooters is probably for the best for everyone, though I can see some people on the e-scooters wondering what in the world's happening as they are riding, maybe not as fast as they'd like down the Beltline.
So last question that we'll take, and then we'll wrap it up this afternoon.
Okay. At what point will you look to work with private sector funders and businesses? How do you see those relationships working? So in terms of our smart city digital twin research, we have certainly been in discussions with the private sector companies that are both providing the analytics and that are providing the technologies. We were highlighted in a recent report by Arup. They're more on the analytics and application side, where they were trying to basically explore. I think the report is called Digital Twin, but Smart City Digital Twin is one of the aspects that they covered. And we have also been interacting through the Center for Development and Application of Internet of Things at Georgia Tech, which is an industry-funded consortium who's actually provided funding for some of our research in this area, where we're able to link directly with companies, and we've gone and done public outreach together with Microsoft at a IoT event for the public. So far the interaction has been around us learning from them learning from us, and us going together to try and learn from and educate the public. We have not approached them for money directly, but indirectly, I guess we've received funding since they have funded the Center for Development and Application of Internet of Things, and some of that funding flowed through to us. I'm not sure the source of Georgia Smart Communities Challenge is their industry funding as well.
So Georgia Smart Communities Challenge gets our funding from a couple of different sources. One is a partnership with Georgia Power.
Okay.
And the other one is a partnership with the Atlanta Regional Commission. And we have a number of other sponsors, partners that we work with as well around the state. So there was one last question that came in. It says, how do we get more involved with smart cities? Do you have any comments on that, Professor Taylor?
Well, for folks from industry and governments, there are conferences, expos with Smart City in the name that seems like there's one every month that I learn about. Those are great places to go and learn about, what's at the cutting edge, in terms of what cities are doing and what companies are able to provide. Academically, there's a new Smart Cities conference that the IEEE has launched, where there's some community building around that. We have been running a track at the Hawaii International Conference on System Science on Smart City Digital Twinning to try and gather together academics. I know at least one person on the call attended that, not this year, but last year. And so there are pockets of ways to kind of learn about what's happening, to engage with others that are working in this area, whether it's on the industry/government or on the faculty/research side.
Excellent. Well, that's going to wrap it up this afternoon. Thank you so much, Professor Taylor. I'm sure everyone got a lot of great information from your presentation. I know I certainly enjoyed it. So I do want to let everybody know that we do have one more webinar that's coming up on April 14th. That'll be Professor Arti Rao from the School of City and Regional Planning, and her presentation topic is Improving Equity Through Smart Community Planning.
Maybe I just point out what Cynthia Curry posted. I meant to actually say this. The biggest expo is abroad in Barcelona, but the Atlanta is hosting the Smart City Expo this June 10th and 11th, the first and only North American edition of the Smart City Expo World Congress, the biggest smart city conference in the world. And so that is an exciting opportunity people should take note of. I'll certainly be there.
Excellent. Yeah, please do look into that if you're interested in this topic. That's it for this afternoon. So again, thank you everyone for joining us on the Georgia Smart Webinar Series, and have a great afternoon.